Alright, so I'm going to run a test of the audio first. Okay, so apparently I was successful in that. I looked back at the homeworks. Let's see, let me make sure I'm getting my numbers correctly. Here. Here. I looked at the homework grades for, wait a minute. Let me make sure I'm telling you the right thing. Okay, 10 and 11, I thought that people might need some help there, but as I looked at the scores, I realized that's not necessarily true. So what I'm going to do is I'm going to leap off into one of the problems that is going to exist on your final to complete that lecture, since homework 10 and homework 11 came out okay for those who have already completed. So I'm looking at impact problems, and give me a second here. I'm sorry. And I've decided maybe this is the most difficult one. Although yours looks similar, it's not exactly the same. So what I'm going to do is I am first going to grab the picture. And then I'm going to grab the wording. Give me a second, put it right here. So two disks have collided with the initial velocities 15 and an 8. If they have a mass of 4, so this will be your 4, and this will be 2, and the coefficient of restitution of 8. You want to know their speed just after they impact. So the first thing I'm going to do, okay, it is true, I can set a coordinate system up like this, but it is also true I can set one up like this. So in setting the second one up, I would have to say X. Okay, wait a minute. Line of impact. And Y is part of the plane of impact. And immediately, we're going to basically borrow this. Okay, E, okay, so I've got A and B is equal to the velocity of A, velocity of B. Now, I've got to determine a subscript for after impact. I'll say, I don't see an I in here, so I'm going to say that is, or have, yeah, before impact. And F is equal to after impact. I'm doing that for initial and final. And here's velocity of B initial minus velocity of A initial. So I remember, as I remember, whatever sequence I have here, I have the opposite sequence down here. Up here is after impact. Down here is before impact. However, this equation only is useful along the line of impact. And therefore, I can put it in here and say this. How about I do this? Velocity A in the X, F. Velocity B along the X, final. Velocity B along the X, initial. Velocity A along the X, initial. What happens to along the plane of impact? Well, unless there's some friction between objects, the velocity of A, hang on, Y final, okay, is equal to the velocity A, Y initial. Meaning, if it hits, an object hits the wall, it glances off. If it's traveling, 5 feet per second here, and you look at the velocity after, it's 5 feet per second there. Now, the velocity here might be 10 feet per second, and coming off the wall might be 9 feet per second, because it lost energy during this impact along this direction. Of course, this is the plane of impact. If you show the ball when it's touching the wall, you realize this is the line of impact, and this is the plane of impact. Okay, so this is what happens along the plane of impact. So what I also have is A, B, Y final is equal to V, B, Y final is equal to V, B, Y initial. Since these are not very critical at the moment, I'm just going to move them over here, put a little box around them, and then say plane of impact. Now what I need to do is I need to figure out all these variables that I've got. Okay, velocity of B initial, the vector. It looks like to me I've got 8 I, and I could say 0J, but there's no real reason to write that. Okay, the next thing, I'm going to try to zoom this one in to find velocity of A initial. So if you don't mind, I'm going to write, okay, I know it's not a very straight line. Okay, let me move this up a little bit more. Here's my Y. I'm going to take my V. Whoa, hang on, let me cut the volume off over here. Yeah, I think it's okay. I've got 15. Hang on. And I've got, okay, it may not look like it, but 3, 4, and 5. So, I got a velocity here, I got a velocity here. Sorry, my lines are squiggly, but hey. Now, gosh, that looks ugly looking. So as it turns out, here, I'll do it this way. Wait a minute, what happened here? Okay, there we go. Okay, don't like that either here. So the purple angle here is the purple angle here. A couple of ways. Okay, so I'm going to mess with the drawing, and then I'm going to try my best to figure out a way of moving it back. So here, if I take that and move it to right there, sort of makes a little bit better sense. Because this line right here, and then this line right here, but that's the case. Let's see. Oh, good. Okay, I moved it back. So, this is 15. So, I'm going to look at something interesting here. This, I'm going to just call it alpha. This is 15 cosine alpha. And this is 15 sine of alpha. From up here, I can say cosine of alpha is equal to 3/5, and sine of alpha is equal to 4/5. So this makes this, replacing this, it equals to 15 times 3/5, or it equals to 9. This one, borrowing this sign here, and 4/5 equals to 4/5, or 12. Okay, so now I have the velocity. So first I'm going minus 9, and I did not leave room there. Minus 9 along the x, and plus 12 along here. Now I can sit here and I can say MA VA X initial plus MB VB X initial is equal to MA VA X final plus MB VB X final. Okay, Make sure I've got this. That's 4. This is 2. This is still 4. This is still 2. So now, when I look at this, VBAX, that. I'm sorry, VAXI. VBXI is that. So I get 4 times minus 9 plus 2 times 8 is equal to 4 times VAX final plus, 2 times VBX final. Then I'm going to go ahead and make use of this equation right here. And the way I'm going to do that, I'm just going to copy it. Oops, did not mean to do that. I'm going to go down here and put it right here. And I'll make it a little bigger. Now, so first, this term is the same as that term, which is the same as that term. So what I'm going to do is start filling this out. Minus 9. This term is the same as that term, which is the same as that term. Which becomes 8. Now, I can't do anything about the upper except VAX final minus VBX final. Now, what I can do is get rid of all this mess here and consider that this is equal to 0.8 because that's the way it was written for us. So at this point, I have an equation here and another equation here. So, I'm just going to carry things the way they are. Well, no, I'll figure out a couple things along the way. Okay, rewriting equation 1 at minus 20 equals to, well, and I can divide by 2, so I can say 2 VAXF plus VBXF. So if I divide by 2, that makes that. Now there's equation 1. Equation 2 becomes a minus and a minus. Make that a plus. And make that. Okay. So here is what I'll do. Okay, VAXF. What I'm doing is I'm copying this part right here minus VBXF equals to, and then next I'm going to take this value, multiply it times 0.8 and put it over here. And that value is going to be 17 times 2. Huh? Oh, okay. Something happened on my phone there. And it's going to give me a 34 over there. I will go back and check this after I get this. Now, I can add this one to this one. Okay, so if I add equation 1 plus equation 2, this is what I get. Okay, I get 34 minus 10 equals 2. Add those two together, I get 3 VAXF, and that's it. So, unfortunately, I thought it might end up as a integer, but he wasn't going to give it to me that way. And so I, again, am wrong. He did give me an integer. And now I feel more comfortable because that's kind of the way he does. So here's what I'll do. I'll just say this. No. I'll say this. I'll move this over here. And I know this is backwards, but I want to be able to just do like that. And there's my first velocity. Now I can take this 8 and put it in here, or I can put it in here. To me, this one's easier because there's no masses across the front of this. So if I do that, I get, using equation 2, I get 34 is equal to 8 from here to right here minus VBXF. And so VBXF, moving this to that side and this to over here, 8 minus 34, or just simple math. It'll okay, I'm gonna do the same thing. Okay, so there's my two numbers. So what do I get for the final velocity? I get V here. Yeah, that's probably good. V A final is equal to 8 I plus something j. VB final is equal to minus 26I plus something j. Let us go look and see what I've got here. I will do a copy, and I'll go out here and do a paste, and I'll expand it out and move it down a little bit. So A came first, so I look here and I get a 12, and I look here and I get a 0. So what I'm simply doing is copying this to here, and I'm copying this one to here, because these are in the plane of impact. So there's my final velocities. What I'm going to do now is I'm going to check, see if they make first physical or commonsensical. Let's see. Copy. Head off down here. Take a look at this. Does it make sense? Let's look at, what the final velocity of B is. B came in at 8. It got hit by something that's larger. So its velocity becomes, it starts going the reverse direction, a value of 26. This one, on the other hand, is moving. Okay, now what we got to remember, this is our X, and this is our Y. So VB had no Y component, only X component, moving in the opposite direction of a positive. Now, A has two interesting components. First, it came in. Okay, let me see if I can go back and find it. Oh, wait, it's right here. It came in this way. It came in with a positive going that way, positive 12, and it came in with a negative 9. Okay. So now it's going out with a positive I, so it's going out with a positive I, so I'm going to try my best to scale it. So here is 8, and, okay, well, my hand sticks to the desk here, so let's say that's about 12, and as a result, the velocity sort of bounces off in this direction. So the speed final of A is going to be, okay, it's going to be the square root of 8 squared plus 12 squared, which is going to be equal to, and this is probably not going to be, I may be wrong, but I doubt it will be an integer, 14.4222, and the speed final of B is simply, I mean, if you want to put it in there, 26 squared plus 0 squared is equal to 26. So in review, and well, let me check the answers here first. I think I can find out how to do that. Okay, give me a second. Okay, 1589. Remember that number. Let's see if that is the appendix. 1589, 1589, 15. Okay. I don't even know where to guess to start. So I'm going to go right here. That's 12. Oop. Oh, wait. We've got an error here. So we've got to work this one out. I have to keep working until I fix this. So I did not pre-plan this. So first of all, let me make sure I'm looking at the same one. Hang on. 1589. Let's see if we can find out. Okay, wait. Okay. 1589. I'm going to snip it. This is what he says. Let's see what I've done wrong. If I can, I don't know where to put it, so I'm just going to put it right here. Okay. It's very possible that I have goofed up a sign, so let's make sure that I've done everything the correct way. Second thing is I need to make sure that I've broke things down correctly here. So this lecture is going to go past the time that it should. And let me see if I can find out what I've done wrong. So here's 15 cosine. Okay, did I do the cosines correctly? Those two angles are the same. 3/5. That would be 3 times 3 is 9. Okay, over here 15, or the sine is 4/5. Be 3 times 4, or 12. Now the 9 is going this way. The 12 is going in the positive y. Okay. All right. So we're just going to meticulously go through this. We know this seems correct to me. Now, we only work this equation and that equation along the line of impact. Make sure I have my masses correct. 4 and 2. So we get a 4. And I'm only interested in these components going in here because this is along the line of impact. VAX minus 9, 2 times VBX, which is 8, 4 times VA, and 2. Now, he says the coefficient of restitution is that. It is the final over that. Now, let's see. Did I do that correctly? 0.2. Now, okay. Let me use the calculator here and verify a couple of things. Okay. It's be 20. What? Oh, yes, 20. Okay. So this is going to be minus 20. Okay. That's what I get there. Then I get a, okay, so if I carry equation 1 down, and I take a 2 off of everything, I get a 10 here, which is 20 divided by 2. I get the 2 here, which is that divided by 2, and I get this, which will be that divided by 2. Now, okay, let me verify this. Hang on. Okay. Okay, times 2. What? That, I don't know what happened here. There's my mistake. There's where I did my big faux pas, so to speak. So my faux pas came in the left-hand side right here. Here's what I've done wrong. this here, here, green. Okay, so if I take this equation, it's VAXF minus VBXF equals to 0.8 times 8 plus 9. Okay, that is, do not believe that is 34. 8 plus 9 is again 17 times 0.8, 13.6. There is my mistake, 13.6. So this becomes 13.6. Okay, now with that, 13.6 minus 10, 3.6 divided by 3 is 1.2. So this is and here you can say 1.2. Now, if that's the case, this is not, okay, so 2. Okay, let me take 2 down, and this on the left hand is 13.6. VAXF is not that, but it is 1.2, meaning, hang on, that this becomes 13, whoops, 1.2 minus 13.6. Okay, 1.2 minus 13.6 minus 12.4. Now, let us fix this. Believe it or not, the only two that get fixed are those two, because these remain from right here. So V, the term that goes right here is VA final, which is this one, 1.2, and the other one is minus 12.4. So, redoing the diagram, then these values are different. Okay, so this does return, the B returns back the other way, and it returns 12.4, and this one does return this way. However, its scaling is quite a bit different. This is 1.2, and this right here is 12. So what do you get? You get 1.2, and over here you get 12.4. This will give you 12.4, and this will give you something besides what I've written there. I'm going to rely on my, well, yeah, I'm going to rely on the picture mode to do that one, because it did it before. I think it should be able to do it again. And it's 12.06. Okay, now, were we correct? The speed of B is 12.4. The speed of A is about 12.1. So the sequence that I've done was correct. My failure came in not doing the math associated with these terms combined together. They were not the correct value that I had, and therefore we still got this done inside the official class period time. So I'm sorry for my mistake, But if you watched it through and you caught it and it bugged you along the way, then you were rewarded by seeing me fix it at the end. But the key here in solving this type of problem is identifying the plane of impact and the line of impact, and realizing that this equation and this equation are applied along the line of impact. And that's pretty much it. So I'm going to call it good.